as we wait for Chris to organize himself a little bit.
Okay, I think I'm good. Am I
Chris, are you
good?
ready?
Hello, am I good?
I think
Mic
the
test.
registration
Yeah, you're
for
good.
the next cohort, I
Awesome.
think
Okay,
Yeah,
we
for
can hear
cohort
you.
3 has been ongoing.
All right,
Today
thank you.
was
You're good.
So I'm Chris, or known as Winter, and today's main focus is Wi-Fi, a bit of Python, and a reason why, or why do you need coding to be a pen tester, a SOC analyst, a code reviewer, reverse engineer. It's a very broad field when it comes to security, because we have different categories with different knowledge requirements, right? For example, if you're doing something like a pen test, and there's another person you're doing reverse engineering, essentially what you two are doing is cybersecurity, but it's on a totally different spectrum or domain. Yeah. So why do you need coding? Any sort of language, or just like a weapon by your side, which is called programming or coding? Why do you need it? And is it really necessary? Is it? Yeah. Okay. Yeah. As I said, I'm Chris. I'm the captain of Freaks Mini. I can see the vice captain is here, and I'm glad. I'm also the I'm also a cybersecurity trainer at Cybersecurity. If you're a beginner and you're really passionate about cybersecurity, 100%, especially ladies, I'll recommend you to try your best to get picked for the Cybersecurity program. Ask anyone who's from there. I was from there, cohort one, I was there. And what I got from there was really interesting. So this is not a marketing, but this is not marketing session. So let me just proceed with what I was supposed to talk about. So I'm gonna tell you reasons, or I'm gonna try to tell you my reasons. Yeah, you can come up with your own reasons on why you don't need or why you need coding. Yeah, I have friends who really don't know anything about coding and are very good at pen testing. But now when there are some things that are needed to be done, they go a longer route as compared to someone who has coding. Yeah. So having the knowledge, or having programming knowledge uh, by your side, is so beneficial that uh, most what they call most companies really wish, like they want, if you can find a JD that's telling you maybe you should be good at automation, or what's it called, or something, bash, python, and you're like, what, this is just pen testing, how, why should I be good at this? The reason being is everything you're using for penetration testing or cybersecurity is written in a certain language. Yeah, be it C, be it Go, be it what else, be it bash. Bash is a scripting language, or it's also what's it called, is it an interpreter, or the terminal itself? So yeah, if somebody came and asked me, hi, I have a question. I want to get into cybersecurity and I don't know how to. The first thing I always tell them is kindly use the first thing I'd say, learn Linux fundamentals. Start with Linux, and then move from Linux to some basic, or some language you feel comfortable with. If you're aiming for web, learn JS, learn HTML, learn those web-based languages that are out there. This will just help you when you're doing your own general uh, testing on websites. Yeah, you know when you see a JavaScript, you know when you see this JavaScript code, and you know this one will need WebAssembly, or this one will need to like just run this in a sandbox, because maybe it's downloading something from somewhere, and then it's making it do something on your browser, or maybe on your system itself. So having that knowledge helps most of the time. So For today, I'm gonna go through. I know most of you have the basic understanding of Python. If you don't, I'd really suggest you start learning Python. It is not the best, the next big thing or anything like that. It is something which has been here, and it anybody who knows Python will just tell you this is very easy. It's very easy and very useful. Be it you're in cybersec, be it you are not in the tech space, you just need something to do some automation. The moment you have opened your machine, you want something to happen, you can either use any scripting language, but Python is the easiest one. So there are many reasons on why you should learn programming language when it comes to pen testing or cybersecurity. Take this as an example. You are a security analyst or a pen tester. You have been called by another company and given work, told, kindly, we are giving you, uh, you are already in our system, like it's an internal pen test. Yeah, this is where now you are given access to one of their devices, and now you're being told from here they want you to like cause havoc, hope to other machines, hope to other subnets, right? So what next? The only thing in that machine is the basics, Python, Ruby, Perl, and all that. But there's no nmap. Although there are static binaries nowadays, you can actually download, or let's say you don't have access to the internet. This is an internal network. Yeah, they have their own services. You are not allowed to access the internet. What will you do? Will you start saying, "Oh no, I don't know about this"? Me, I was taught when I get into an internal network, I set an nmap scan, and when I get this, I get an internal web service running. I'll fire up something like Ferox Buster or Deer Buster or such tools to like gather more information. Yeah. Now you see, you'll be stranded. But now check, this person knows uh, this language, bit bash, Ruby, or anything like that, and he knows how to interact with the environment. Yeah, using Python, it can create something similar to BAP. Like this is just BAP is just a proxy, so you can create something similar to that, where now the traffic's been passed to Python, and then it uses Python to do some things, and then it forwards it to the destination it was supposed to go to. Or maybe it creates, automates, maybe there's netcat, it now starts enumerating for ports using netcat, and now it needs bash. Yeah. So that's one critical reason why you need a little bit of programming. Now that's for the red part. Now let's go to the blue part. Yeah, you have a huge log file. You have tools. Yeah, you have lots of tools. But now you want to present it in a way or make your work easier. You need a way to do that. You need a way maybe to pass from one file format to another. There are tools, yes, but maybe you need it as fast as possible. You can actually create scripts to do that for you. Yeah. So there are various reasons. So when somebody tells you you don't actually need programming to get into cybersecurity, I'll refute that. I'll say yes, you can be a cyber security or a security analyst without coding, yeah. But now, if both of you were to go to an interview, me and you, I know one language, you know none, but you're better at me at pen testing. Now, I ask you, what will, if it's not a technical one, and maybe you're just being asked, what are your skills, what do you know, and stuff like that. Now, when I say I have like I have a prowess in Python, and you hear you say I'm just good at pen testing, and you're asked, do you know any, or maybe you're told a question like, if you get into an environment and you cannot do this and this and this, and you only have this, what can you do with it? Now, I'll have it easier to explain, even though I have one programming knowledge. If they ask me another programming language, essentially programming is similar across the board. The only thing that changes is the syntax and maybe the way it's written or something like that, or the way it's run and stuff like that. So if I know one, I essentially know a quarter of all or a third of all languages. Yeah. Because when you know one language, you know very well there are rules that I need to follow. So when you're going to a new language, you'll just start asking yourself, what are the rules in this language? Yeah. What is the syntax to be used in this language? Now you find it easy. Something like loops, they're same across languages. we have loops and we have loops and conditional statements. So you really need a programming language to get into cybersecurity, to prosper or to progress more in cybersec. Yeah. So for today, I'm gonna talk. It's not a Python session. It's more of a wireless, which is Wi-Fi session, where we're gonna talk about the Wi-Fi or the wireless protocols, and now we're gonna move on to like start uh, using Python itself, start performing something like recon uh, on the network, or recon for the wireless, recon for getting all wireless networks around us. And then we're also gonna try and imitate an access point and try sending beacon frames left and right, and we learn about what are the disadvantages and advantages of such. So yeah, any questions on Python or maybe scripting from there? Because now we're gonna dive into Wi-Fi, and then after a while we're gonna now dive into Python, where we're gonna go hands-on and try to uh, see what we have in the air. Yeah, anybody with a question up to where I've talked about the reasons you need? Yes, James. Hi, James.
Yes.
Yeah, I see your hands up.
Yeah. Yeah. Mine is a humble request.
Okay, cool.
Yeah. Is the session being recorded?
Zeddy, back to you.
Yes, it is.
Okay. Thank you.
Awesome.
Thank you.
Yeah, it
Awesome.
is.
Okay, thank you.
Okay.
Okay, awesome. Now, let me just share my screen so that I proceed. Where is it? Where is it? Where is it? And then, just a sec, just a sec, just a sec. Where do I share this? Google Meet. Entire screen. Allow. Can you see my screen?
Yes, we can.
Awesome. So, uh, now I have a question, a quick one. Who can tell me what Wi-Fi is, or what is Wi-Fi to you? Yeah. If I just come and ask you what is Wi-Fi, yeah, what would you say? Anyone? Anyone? I can't see your hands up. So, if you have anything you wanna say, just say it. I can't see the hand, so you can just proceed and tell me your take. What is Wi-Fi? Yeah. Uh, okay. Yep. I also don't know what Wi-Fi is. Sincerely, if I ask you what Wi-Fi stands for, yeah, let me just ask that instead of asking what Wi-Fi is. I want to ask you what Wi-Fi stands for. Yeah. Let me just check there on my own because I can't see your hands. No one. Steve, what is Wi-Fi? What does Wi-Fi stand for?
Wi-Fi stands for wireless fidelity, network
Wireless
support.
fidelity. Are you sure? Tell me you are 100% sure.
Yes,
Yeah, right? No take
yeah,
backs. Okay, cool. James,
that's correct.
From the chat.
yeah, there are charts. Let me see.
Yeah.
Yes, what is Wi-Fi to you?
Wait, Winter.
Yes, hi.
Okay, okay. To me, is
You can
is a technology used to connect computers, tablets. Yeah.
Awesome. So now, what is Wi-Fi? Like, that is your definition of Wi-Fi, right? Awesome. Thank you. Another person, I had someone trying to speak. I don't know who was it. It was a lady. It was a lady. Hi, hi. Uh, anyone? Veronica, tell us what's Wi-Fi? Yes. No one is sure what Wi-Fi is. Seriously, we all use Wi-Fi. Uh, Jacinta, what's Wi-Fi? No, wait. Is this the Jacinta? No, Jacinta. No, let's not go to Jacinta first. Let me go to who was it that raised their hands? Lenny. Yes, Lenny. Hi, Lenny.
Hi.
Hi, hi.
To me, I think Wi-Fi is wireless fiber interconnection.
Wireless fiber interconnection. Now that's interesting. Huh? We have Cyber Genie or Genie. Genie is the nini.
Yeah.
Hi.
Hi.
What is Wi-Fi?
Okay. Wi-Fi is actually radio frequency.
Yeah, awesome. Yeah.
Yeah, which is very strong and is used to make a connection between computers.
Yep, that's true. That's very true. Uh yeah, and the other thing is Wi-Fi an abbreviation? Is it an abbreviation for anything? Yeah. Aha, cyber Genie.
Yes.
Yeah.
Okay, Wi-Fi
Uh-huh.
actually stands for wireless fidelity, whatever, something like that.
Okay, awesome. Uh,
Yeah, actually, that's what it stands for. In the real sense, that is not the full meaning.
okay, thank you. James.
Yeah, it is stands for wireless fidelity.
Awesome, awesome. So shocker. Actually, Wi-Fi, the term Wi-Fi, I also came to know this recently. Uh, or let me give it to someone to say this. Hi, Jacinta, I saw your hands up. If you can speak, kindly speak.
Hi.
Hi.
I wanted to help out since no one had their hands up on the ladies' side.
Oh, okay, cool. So, Jacinta, what
Yes.
is Wi-Fi? Is it an abbreviation?
No, it's not. And
It's
yes,
not.
it is
Yes,
because
it is.
technically it is not
Uh-huh.
an abbreviation.
Uh-huh.
But when it comes to layman's terms, it's what people have come to associate a wireless network with. So it's a trademark by a company called Wi-Fi Alliance. So it introduced the term wireless fidelity as a slogan, as something to represent Wi-Fi because the technical is very difficult because it's difficult to keep saying IEEE
Yeah.
802.11
Awesome.
standard as
Awesome.
it represents that standard for um, wireless communication.
Thank you, Jacinta. Yeah. You deserve a sweet. So you can text me offline and then ask for your sweet. Okay. Yeah. Okay. That's it. Wi-Fi is not wireless fidelity. Like technically, it is not. But when you talk about the marketing aspect of it, it was just made in a way a layman could be able to like. You see the way it is sweet in the mouth. It is smooth. Wi-Fi, wireless fidelity. No, Wi-Fi. It is just the IEEE 802.11. That's the standard. Yeah. So for you to know or for you to be able to easily like when you're asked what you use, you'll just say, mi niko na Wi-Fi. I have a Wi-Fi. Yeah. You won't say, oh, me, I use IEEE 802.11. You see, it's so most of the time you might find a very huge debate on uh, what is Wi-Fi exactly, the abbreviation itself. What does it stand for? Okay, personally, I think it's meaningless because language is language, right? So long as it's in the dictionary and it's uh, like a huge and a large number of people agree with it, obviously you as one person, the uh, like the crazy one, you can't come and start convincing a million people to do it otherwise. So I always find that convo to be meaningless, but it's good to know. It is a very good fact to know that it is just a marketing slogan. Yeah, thank you. That's that. So Wi-Fi nowadays is everywhere. It's not like back then where it was very rare to have Wi-Fi. You see, so back then you'd like really wish for it for Wi-Fi. But nowadays, when you go to someone, you go to visit your friend, you won't even ask, "Do you have Wi-Fi?" Password your Wi-Fi ni? That's the thing you'll say. Password your Wi-Fi ni? Because you'll find it so strange if they don't have one, if they don't have a Wi-Fi around them. And now that's scary. That's very scary because everything uses some sort of wireless technology. Yeah, and I am glad somebody brought up the fact that Wi-Fi or wireless wireless is only something that falls on the radio spectrum, right? Just further from the infrared and microwave. Wi-Fi and a bunch of other wireless technologies falls in that range. Yeah. So yeah, it is all around us, and if you don't have it, if your school doesn't have it, now that's pretty weird. That's very weird. Almost even nowadays, even if you go, I had gone to uh, Akibandaski around here, and when I got there, I just see they wrote up their free Wi-Fi, and I was like, where? You see, even such a place itself has Wi-Fi, meaning everybody in here who's using this Wi-Fi is a potential target. If I just decided to say now I'm going rogue, yeah, everybody who comes here to buy uh, one bottle of soda just because they want to update their status is a potential target here. You see, so Wi-Fi is or wireless. Wireless is a very critical part, which is sometimes not taken seriously because nowadays you don't even care if somebody is trying to hack into your Wi-Fi. No, you don't even think somebody will dare do that because they have their own. Why would they want to hack yours? Yeah. And you also can't fathom the reason why somebody will want to hack into your Wi-Fi network. They will be like, sasa anataka kuingia kufanya kuchukua nini? Kucheck if I'm watching Netflix or something like that. But remember, it is your network, meaning everything you're doing is sending, the packets are just over there so you can see all of them, although it's not in plain text or you cannot view them. Yeah, it can do some other crazy stuff from that. And in all households, if it's not an enterprise network, in all households around us uses their not all, I think some of my friends have their own DNS servers, but it uses the AP or the access point as a DNS server, right? So meaning everything is being resolved by your access point. And that's pretty crazy. I'll tell you why. So yeah, that's Wi-Fi. Yep. And in Wi-Fi, we have various distributions or various flavors, which we have one is ad hoc or tethering, which now wireless or what's it called? Hotspot. Yeah, or hotspot. The next one was the bridge, which is now an AP to an AP, or maybe through a wireless distribution system, or maybe it's just wired to maybe something like a wireless port or ported like that. Yeah. Now that's for bridged. Yeah. You check it as an AP to AP, communication between AP to AP, right? And then the other one is the infrastructure. Now this is what we all use. Yeah. This is like a bunch of, this is one AP and a bunch of clients connected to that AP. Yeah. So Now this is where I'm telling you it's crazy. All traffics are going through this one single AP. Yeah. And now what the ESSID is just like is it the ESSID? Yeah, ESSID is like some sort of MAC address of the AP. And then we have the SSID. Now the SSID now here is like a string. The name of the Wi-Fi is always 32 characters long, if I'm not wrong. It's 32 or less, yeah, characters long. So it's the name of the, if you are scanning for Wi-Fi and then you see the Wi-Fi is called Mkuu or maybe Bazenga, that's the SSID. Yeah, it's a service set identifier, if I'm not wrong. Yeah, I think it's service set identifier. So those are the distribution or the types of flavors of Wi-Fi we have around. Yeah, and this is where most of us fall under the infrastructure one. So yeah, Wi-Fi packets or frames. Let me call it frames, not packets. Shit. How do I go back? Awesome. So that's how it. I cannot edit it. Okay. So call it frames, not packets. I call them recon freebies because these frames, they have no encryption or nothing like to see to check if it's actually a legit one coming from maybe an AP or a client. All of these are sent over clear text. So this tells you it is very easy to perform a recon on a wireless network. If you're connected to a Wi-Fi, you can get all the devices, the names of all the devices connected to that network. Now you can go and proceed maybe to whitelist yours and perform a denial of service on all of them. So you're the only person who's able to connect to the internet. Everybody's trying and they're kicked out, because you're already done a recon or you already done some investigation and seen, oh, this is the MAC address connected, and this is another one, this is another one. Now you blacklisted or now whitelisted yours, and now you are kicking everyone. This is called the authentication from the NINE. So now we have the management frames. Now in the frames, management frames is just like the access point or your router, your Wi-Fi is telling the clients, your phone, what to do. Or now your phone is telling them the AP what it wants to do or what to do. Yeah. And then now we have the control frames. Now this is like asking or maybe uh, a form of controlling the way data is being sent over. Like we have the request to send and clear to send. Like you see, the names are tells you everything, and you also have the power save or power controls you can perform in the control frames. Now here in the data frames is where your data is. Yeah, whatever you are sending over the internet or over the wireless communication is all in the data frame. Yeah. Each one of them, when you capture, they have different IDs. You're gonna capture traffic with using Wireshark and see the difference in these. Okay, cool. So yeah, now we've known we have had Wi-Fi since, when was the first time Wi-Fi was introduced? Can't remember. When was it? I can't really remember when Wi-Fi came to be, but it's now a part of us, a part of our lives. And we all want to have privacy. So we have to be mean to the neighbors. You have to deny access to them. So question time. What is the way or what are the various ways you can actually deny access to your neighbors or maybe be mean to them, as the way I put it? What are the different ways you can actually do that, if anybody knows any? Oh, 1997. Yes, Joel?
You can hide your Wi-Fi's SSID.
Look, hide SSID, but there's a simpler way, a very simple way to do that in Python to get hidden SSID. Very easy. So hiding an SSID is definitely a way to be cheeky, not really a way to secure yourself. You can hide, yeah, but when I get it, because now that's the only form of mechanism you put in place to be mean to the neighbors, the way I put it, I can just connect because I already now found your SSID. Any other person I saw some charts. I saw password. Yeah, correct. We have password. Any other way? Yeah. Okay. I have this question again. How many of you here? Yeah, whitelist. Yes, whitelisting devices. Correct. That's another way. But it doesn't work all the time. A limiting number of users. That's even better. But I can perform a deauthentication attack. You see, everything has a but to it. Everything that is being set to minimize or to control access to your Wi-Fi access point or Wi-Fi network has a but at the end. Everything you say, I'll just say but, but, but. That tells you how it is scary to our as somebody who knows what to do at your Wi-Fi around you, and you are not aware on how to protect yourself. Yeah. So, any one of you who has gone, somebody has talked about whitelisting. Now, this is what I wanted to ask. Anyone of you have been to Java? Yeah, you have gone there to maybe have a drink or have something to do, or you just want something to a bite, right? Yeah. How many have been to Java House? Is it Java? Yeah. Aye? No one. No one has been there. Huh? I just want someone to tell me what happens there. Yes, Steve. What happens there when you pay or when you buy something and you're waiting to like you want it, right? What happens at Java? Yes, Steve. You've gone to Java. When you
Hello.
got there, what happens? Yeah, hey.
Sorry, I didn't quite get your question.
I asked how many have been to Java, and at
Okay.
Java there's something unique about them. That's it's very unique. When you go there, you want to eat something or you've ordered something. There's something that happens, or there's something they do, or they give you. What is it? And
Mm,
huh?
not
You're the
sure.
guy.
Sijui gani ni
The
gani.
password.
Yeah. Ooh. Okay,
The
Daisy, I can hear
password
the password.
to the
Yeah.
Wi-Fi or something.
Exactly. They give you your Wi-Fi password. And the thing about that Wi-Fi is it's limited to 4 hours, right? And the way they do that, yeah, yeah, something about limiting your the way they do that, they use whitelisting. The moment or maybe they put a counter on your MAC address. So the moment you get there, they give you a Wi-Fi password, and now you'll be able to connect to the internet for as long as 4 hours. So this one is they're limiting people to come there, buy a cup of iced tea, or yeah, and then sit there the whole day with their phone, just browsing or maybe doing their work there, right? They want you to you'll just be able to use it for 4 hours and then you leave. There's a time I went there with a friend, right? And then we were curious. We had connected, and I was like showing him a bit of cybersec stuff and left and right. And then suddenly the Wi-Fi got connected. We bought only, let's say, drinks, right? So we were sipping them slowly, slowly, so that we seem like people who came there to eat something. So it got cut off, and now we were serious. And I just said, let me try changing my MAC address and then reconnect. Boom. As simple as that. You could just change your MAC address and you have an additional 4 hours for each MAC address you change. So this you could make something like a rotation, a script to rotate your MAC address. After staying for 4 hours, the script kicks in, changes your MAC address, reconnects you still have internet. So in short, this gives you the ability to stay at Java for like you can make it your second office. Yeah, just go there in the morning, buy a cup of coffee, do your stuff, lunch, buy something like a burger, do your stuff. When they're in the evening, buy another cup, continue doing everything. Yeah. So that is a way they're actually now that's for limiting. That's not actually for security, but that's for them to like and not allow people to stay there for long because trust me, if they put it unlimited Wi-Fi, hey, there are people called us. We love free things. will stay there almost every day. You go there just for the Wi-Fi. Yeah. Okay. Yeah. Those are some of the ways you've told me. But now we have protocols or standards that actually ensure that our Wi-Fi is protected, our Wi-Fi network is protected, or our data being sent over the wireless network is encrypted. Yeah. And we have a couple of them which came. I'm gonna show. Yeah, just showed it. I don't know how to shift without starting over again. This sucks. Oh shit. Shit. Why are you doing this to me? Awesome. Yeah. So yeah, the first one we have web. Anybody just shout, or maybe let me pick someone. Jacinta, if you see any hands up, just stop me and call them out so that they can talk. So when I ask a question, just do that. So anybody just tell me what web is, yeah? When it comes to wireless security, what's web? Anybody who knows, who doesn't know in Wi-Fi, what's web? Anyone? Just a quick one. It's a simple one. Just very quick.
James Morade.
Yes, James?
His hand was up. Yeah,
Oh,
James.
hi.
Is wireless encryption protocol. Protection that is.
Wireless.
Yeah, encryption.
Are you sure
Yeah,
it's
and
wireless?
encryption.
Okay, cool. Thank you, James. Anybody else? James has tried, and yeah, when you see it as web, you'll think of whatever you said. So anybody else would love to try? Anybody? You don't want thank you. I have a thank you here to give out. Anybody who wants to try?
Winter.
Hi.
Wireless equivalent.
It's
Wireless equivalent privacy.
I can't see who's speaking.
There are two
Wireless
people.
equivalent privacy.
The wireless equivalent privacy. The next person was who called me Winter, the one with the alpha voice. Hi. Hello.
Someone has answered in the chat.
He said.
So Hina has said wired equivalent privacy, and Simon has also said wired equivalent privacy.
Yeah.
I
Now.
still have one hand up. Karanja.
Yes.
Disappear.
Okay. Yeah. It is pretty misleading when you see web, and the first thing, because this is wireless or Wi-Fi, you think it's wireless, right? But no. The concept here was to create some form of encryption or something similar to the way wired works, the way Ethernet works. You see, so it was wired equivalence privacy. You see, so it is not really wireless; it's wired equivalent privacy. So yeah, thank you guys. What about WPA? WPA. This is a cool one. Yeah, this is secure, right? It's very secure. We have WPA. No one's up. Nobody wants to answer.
Wireless protected access.
Wireless protected access. Anybody wants to dispute that, or anybody wants to say another thing? No one.
Stanley from the comments has said Wi-Fi protected access. Same with Joy.
Oh, awesome. Anybody else? Are those all? It can't be wired. How are you sure it's wireless? It can't be wired. Yes. No wired anywhere. No. Nobody thinks it's wired. Just a sec. Nobody thinks it's wired. Yeah, okay. Those who said it in the comments, what did they say? Wireless?
Wi-Fi protected access.
Yep, Wi-Fi protected access. That's it. We have WPA for Wi-Fi protected access, and then we have WPA and WPA3, which WPA3 I'm not touching on for today. I'm not touching on WPA3. You'll not hear me talking about WPA3 because sincerely, I don't know. I don't know about WPA3 because it is very interesting in its own right. If we're talking about the three, W web and WPA, WPA2. So now we have the wired entry point, right? We have the wired entry point or the wired equivalent privacy. So the reason why I call it wired entry point because it's not a way. The privacy in that term is, should I call it? Or what's this called? Like it calls itself wireless equivalent privacy, and there's nothing private about it. Like this is so easy to crack. Yeah, it's so easy to crack. So the reason being, now this is a 128-bit it is a 128-bit key with a 24-bit IV and a 40 to 104-bit shared key, or what we call PSK. Yeah. So why am I saying this is so broken? Is because of that 24-bit IV one and then the 40-bit shared key. So if you ever done any brute forcing before, the moment you see 24-bit key and 40-bit, the key itself, let's leave the IV because the IV is easy to get because in web it transmits the IV on in plain text. Yeah, and we're gonna see why and what I mean by that. So and then it uses the RC4 stream cipher to do this, and there's a CR32 checksum just to check the integrity, and then there are two modes for web. One of them is open and the other one is handshake, right? Or what is it called? Should I say enterprise? No, it's more of, it has a shared key, yeah, or say PSK, personal shared key. So there's a thing, what we're talking about the key itself is now where the key is being sent. So in open is this Wi-Fi you find all around you that have no uh, security to it, right? When you connect, you just connect, there's no security. So when it's in web, you have the option to use web or encryption, where now your data will be encrypted using the web, the wireless equivalent privacy, and also you have the option not to use it. So they are always set in a way that if you use web, you can send the key. If you send the key, it will use it, but if you don't send it, well and good, it won't use any kind of encryption to make your communication private. So in the handshake authentication, where now there's a pre-shared key, yeah, the thing that happens, or why I'm saying this is very, very, very weird, or very broken, is the plain text is exposed, like it's just there. When you initiate the handshake, the plain text is sent over to your device, right? In plain text, the IV is sent with the IV is sent over to your device in plain text, and then you are the one to encrypt that IV with a key, right? Or you have to encrypt the IV and then return it back to the AP. Now, this is easy because all you have to do now is just to brute force that for the RC4 key. Yeah. And also the other thing is the 24-bit IV, which now we're gonna, which was actually improved in TKIP. What this will cause, it's something called collision. You see, when it's just this broad or this space of 24-bit, after a period of time, there will be two devices that will have the same IV, right? And now that causes what we call now collision. Awesome. So that's it for wired entry point or wired equivalent privacy. Don't take it as wired entry point. This is just a way I put it. Now. Yeah, we have the big one, WPA, which everybody is using. Everyone is using WPA. Right now, if I just count, I'll just find people using WPA or WPA2 in this. So this is where if you find anybody using WPA2, you just start smiling because super duper easy. Yep, it is the Wi-Fi protected access point. You see that it is web kinda does that, but it has its own issues. So that's where the kinda comes in. Now it uses something called TKIP. Yeah. Now this is temporal key something protocol. I've forgotten what it is. Anybody who knows, it is temporal key something. The I is eluding mind, but it's temporal key something. The I, anybody would tell me what TKIP? The I is disappearing. Oh, anybody tell me what TKIP is? Anybody can just do a quick Google search. Just tell me what it is. It is temporal key. The I is
Integrity protocol.
yeah. The temporal
Protocol.
temporal key integrity protocol. Yes. Now this is more of hashing keys and like giving out a session instead of now giving out. Let me just. No, mixing instead of concatenation. The way Nini does it, the way web does it. It concatenates the IV. If you go back and see, it concatenates the IV plus a 40-bit or 104-bit shared key, right? But now here in TKIP, it does something called broadcast randomization. Yeah. Where now it's gonna randomize the positions of the different hashes that is related to the encryption. Yeah. So you see, the session key, we append the IV and we still use the RC4. Yeah. And there's sequencing or numbering. This helps you in like tracking your packets or something. And then we have a 64-bit integrity check called MIC or MIC. Yeah. That is message integrity check or MIC. Now, this is not on all access points, but there's always a slight delay of, that's the way it's mentioned there, a slight delay of 60 seconds when you key in two invalid mics, and then now this rotates the session keys, and then now that rotation 60 seconds. So imagine every time you perform, like this one, like just leads to DOS exactly. You'll be unable to, or somebody will be unable to connect because this is done on the AP. So when the rotation is happening, yeah, that's 60 seconds timeout. Now that causes a denial of service, right? Because 60 seconds is a very long time. Say, have you ever been waiting for something and you just see the seconds are ticking? Even 4 seconds is long. Yeah. Okay, awesome. So now that's for WPA. Now these are simple. These you can all of these can be cracked. You can just capture the handshake and then perform a brute force on this, and you just need to get the session key. Awesome. Now that's for that. Now it is here where what it says, it fixes the it fixes web, sorry, OWP. It's because it expands the IV. You remember the IV was 24 bit here, but now here it expands it. And then I think, is that in WPA2 where it uses a yes? Okay, I think it's WPA2. Okay. So this the expansion of the IV reduces what I talked about is the collision, right? And now here also where I talked about the broadcast key rotation, where now it's just rotating the session key so that there's something called an induction attack. Now, what we mean by induction attack is the attacker will send a bunch of packets, yeah, and then check for a pattern on the way it's been encrypted, and definitely they find a pattern, yeah, and from that finding that pattern they can proceed from there and maybe do something else. And also it prevents what we call replay attacks. Now that is the message integrity check which prevents the replay attack. Now in replay, let's say uh, a client sends a packet that contains a session, or maybe contains a way to connect to the AP. You can capture that packet and replay it. Yeah. Now by replaying it, you just send it as you to the AP, and then you'll be able to connect. This also tries. It doesn't really do it well. It tries to prevent man in the middle attacks. Now WPA2. Yep, CCMP. I really don't know what this is, and I won't lie to you. Counter cipher mode with blockchaining messages. I don't know. I only know it uses AES block cipher, which is a very cool kind of encryption alg. And then it uses the PBKDF to generate. It uses the PBKDF to generate the encryption key. So basically, PBKDF stands for, is it pin or password-based key derivation function? Yeah. So it uses that to generate the key or the pre-shared key. etc. Now, yeah. Now we've learned about the encryption and such, right? I don't know who will use this, who will, in their right mind, just say, I'm going to use WPS. Yeah, because WPS is, I'd say stupid. Like, I'm sorry if any of you contributed in WPS or Wi-Fi protected setup development. I'm sorry to tell you this. This is super stupid. Like, WPS, this is like a pin, a 8-digit pin that comes on your router. It's just behind it. It's like a sticker placed there. And now you can use that to like authenticate to an AP. And the weird thing is some access point like generates the pin based on the ESSID. Or is it the BSSID, not ESSID? The BSSID, yeah, or the MAC. So you see how this is simple to do, because cracking a 8-digit pin, that's simple. If you have a machine like a guy known as, I don't want to call his name, he knows his name. If you have such a machine, such a beast like machine, you can just brute force this in like minutes and get the pin. So yeah, now how are they broken? We have a bunch of suits or a bunch of things you can use to actually pen test or break down Wi-Fi, right? So we have the air cracking G suit, which now we can use to perform various or plethora attacks like deauthentication, replay, injection, fake access point, and capturing, right? And then we have John the Ripper now, which we use to crack a captured handshake. Because when you want to want to pen test or get a password from a Wi-Fi, you remember we talked about a pre-shared key, yeah? Yeah, we talked about a pre-shared key, yeah? Now we can capture the handshake between uh, the client and the AP. After capturing that, now we do a dictionary-based attack, right? Where now you generate different handshakes that you don't actually crack it. That's what I came to realize. You don't actually crack. You generate uh, different handshakes and then do a comparison. And then when it's similar, it gets a hit, and then you have the password. Yeah. So yeah, now that's John the Ripper, but most of the time, I'd say, not just in Kenya, but all around us, it is kind of hard to crack somebody's Wi-Fi password unless you're a pro at generating passwords. Because nowadays people, oh yeah, it's easy, I guess. Because uh, what is yeah, Steve? Yeah. There's a time I saw somebody put his Wi-Fi password as Steve Simple Boy. So this came to me, and I just realized that if I want to hack into uh, any persons or any Kenyans a Wi-Fi, or maybe just guess their passwords, the first thing I'll have to know is number one, their tribe. That's one I'll have to know, because most people either use their language, their mother tongue to create their passwords, or they use trends to create their passwords. Like somebody will just mostly TikTokers, they'll use TikTok slang to as their passwords just to look cool. But that doesn't only apply to them, even tech people. Me, for an example, I use hack the box as my password. Literally, I use hack the box, not as my everyday password, but as my Wi-Fi password. So this tells you that if you knew me kidogo, you'll just generate a word list on what you think I like, and then you'll just start some sort of spraying, right? Because now you just guess like anajita winter. Definitely his username is winter in platforms, yeah? Just try and now do a password spray. You can go and try. Kishikwa de shida. So yeah, it is not definitely easy to crack passwords or hashes unless you have a dedicated servers to do that or machines to do that, which you can leave for days to just crack one password, and you have a large word list. Yeah. So for brute forcing, you need a GPU, and then for Crunch is now to generate the passwords, right? Like with certain rules. The way I've told you, people use like slang, internet slang to create their passwords. You can try and gather all the slangs in your area of locality and try and generate some sort of password from that. Or maybe when it comes to organizations, they tend to use the initial name and or the first name and some sort of extra characters for padding for default password. So definitely try that. Okay. Now that's that. Where does Python come in? Why should we use Python? And we have Aircrack and G. We have all of these sweet stuff. Yeah. Yeah, dope. You can decide not to use these tools, or you can decide to use them. But now Python gives you the ability to chain all this. Like you could chain it using Bash and all that, but now the ability to generate or to create your own packets in a way you want it, yeah. And then now if you're doing a deal, yeah, you know the packets exactly you created and how the deal is working, yeah. Now this the knowledge behind all this and the structure of the packet being sent is more valuable than you just running aircrack in G and then AM1 and stuff like that, and then you get the passwords. Or maybe you capture the handshake. So what we wanted to do today is like give you a brief introduction on what exactly can you use Python to do when it comes to wireless security. So the first part was Wi-Fi, and then the second part we're going to talk a bit on Bluetooth, but not today. So I only have about 50 more minutes to go, and this is where we're gonna start. So Python, Python, you can debate with me how much you want, but after Rust, the next best programming language to me is Python. And then the third best is Go. And then the fourth is C. And then now comes all those uh, other languages. Yeah. So I'll tell you globally, the best programming language is Python. The second best programming language is Python. And you tell me otherwise, that is yours. Oh? That is definitely yours. So yeah. So awesome. So if you've learned a bit of Python, you've learned the basics from variables, lists, loops, and conditional statements, right? So you've learned about modules too. You've learned how to import modules. Yeah. So if you don't know modules, modules is like blocks of codes written by other programmers, right? So that it assists you to, it makes your work easier so that you don't have to reinvent the wheel. You could go ahead and start maybe using struct again to like assemble a packet, which is kind of pretty hard if you ask me. But you could go ahead and use a module such as Scapy just to make your work pretty easy, because now this is a layer-based module. It has almost each and every protocol in each layers. Now you just have to stack them or make them, craft them in a way that it creates a packet. So where? Nope, nope. Where is it? I have notes, I guess. Just a sec, just a sec. I need to. I didn't put everything on the slides. I need to open Obsidian and check out something. Oh, it was here. So it was here. So let me go to 6.6. The web, TKIP, WPA, and here we are. So yeah, I didn't talk about this, but Wi-Fi in yes. Hi. Anybody with a question? Yes, yes, Daniel. Anybody who can access the one speaking, so you can mute them. Daniel, you have your hands up. Any question? No, no. Okay, cool. Let us continue. So yeah, what I want to talk about. Yeah. Blah blah blah. Those are the frequencies. Yep. Here we have it. So yeah, now what we want to talk about is sniffing and channel hopping. Basically, these are what we want to implement. Sniffing, and we're gonna like imitate an access point and like pose as another access point. We're just gonna be doing a beacon flood on the network or over the air, so that we come out as another access point when somebody checks their device. You'll see that there's another access point there, and maybe you could build on top of that and allow make it uh, an open Wi-Fi access point where if anybody manages to connect, right? Now you give them access to the internet. That's one thing most people forget when you're creating an evil twin. Yeah. When you create an evil twin, you don't give somebody access to the network or to the internet. They'll now start asking questions. Why am I not able to connect? And blah blah blah. So the trick there is always when you have an evil AP or you have kicked everyone from the original access point and you have created your own access point, right? And then you'll you'll now give access to the internet, right? And then when that person connects to it, because obviously people will assume they have already connected or they have because they had already keyed in their password previously, they don't have to key it again when they perform a deauthentication attack on them. So they'll come and click on the first, they'll check the list of Wi-Fi or the list of SSIDs. By SSID I mean just the names of the Wi-Fi, and then they'll click theirs. When they are kicked out again, they'll see there's another similar Wi-Fi name there, and they'll be like, "Ah, my Indian yangu, is this one?" And then when they click, they'll just see there obtaining IP address. Boom, is already in your access point in your AP. Now, what you can proceed to do, which you should do, but you can proceed to do because they might be using your AP as a DNS, right? Uh, you can put some of your own rules and maybe resolve Google to your own Google, to resolve a Facebook to your own version of Facebook, like just an interface for login for Facebook. And then when they access such, and nowadays is it easy? Yeah, I think it is. So long as you have you can masquerade as another person's access point, you can actually perform a man in the middle attack, which I'm talking about. So you just play like the man in the middle and then create something like a web interface for Facebook, and then when that person comes and logs in, you maybe redirect them to the original page. They have to log in. Now, with that one, you have gathered credentials for Facebook. That is also something similar, right? Something like sweet you can do when you create an evil twin. So yeah, so when you want to work with Wi-Fi, there are different modes on your interface. We have the monitor mode, yeah, and we have the managed mode. So the managed mode is what also we have three, I guess. We have the access or the AP mode, now where it turns the device into an access point. And then we have the managed mode, which now is the one you always use to access the internet. And then we have the monitor mode, right? Now this one just stands by and then just listens or monitors the wireless networks, right? So there are different ways of actually putting your interface on monitor mode. But because I don't have a Wi-Fi adapter which I can use separately from my internal adapter, I always love creating a virtual interface. Yeah. So you could use this way to like set up your interface to like be on monitor mode. But me, I love like starting up or creating a new what is called a new interface. So how I do that is sudo iw. Okay. Nope. This is sudo iw dev. Should I do a list? My password is not hack the box here. So yeah, if I check the devices, you can check I only have WLO1 as my uh, wireless interface, and then you can see it is in managed mode, right? Connected to the SSID known as Flixbini, right? Meaning I've connected to a Wi-Fi access point with the name Flixmini. Yeah. So this one is on manage mode. So I could go ahead and maybe take this down from manage to monitor, which now will kick me off of I won't be able to use the internet. But I could also go ahead and create a virtual interface that will act as my initial interface and be on monitor mode to work with it. Yeah. So for that, do something as simple as no wait. That's crazy. Sudo AW, and then I think is the interface, and then there it is. I'll just copy that. Sorry. This sucks. Bash clear history. The way we forget about, and then there it is. Yep, now that's how it is. So what I did here is now on the interface WL0, I add a virtual interface, right? I add a virtual interface, and then the type itself is monitor, right? So this is just the name of given it. It's not actually called virtual interface, or uh, is what an argument called virtual interface. No, I can give it anything. Let me say mu underscore CIT or something like that, and then When I do that and then I check for the devices, you'll notice there's a new interface, right? And now it's on monitor. So meaning I can now work or use this interface for to check or to do Wi-Fi pen testing. So here I'll just go and start up. Now this one will fail me. Let me start it up as sudo. I can start up Wireshark so that we can see the traffic that the monitor mode interface that I've just set up is actually capturing. So let's go to 8 and where is it? Can I see it? Can I see it? Here it is, right? Oh, wait a minute. I did not put the interface to be up. So it won't do anything. Sudo ifconfig mmucat. I could have just used w. Yep, and now that should work. So the Wireshark. Go to 8. Dope, and now we see traffic being captured. Yep, now let's reduce this. Now dope. So now while it's capturing, let me just stop it. Let me go back here. Now you remember we talked about the types of frames, right? We talked about the types of frames. So do I have them? Where are the types of frames? No, I think I have them down here so that I can explain. So yeah, so here is it. We have the types of frames. We have the managed, which is now on 0, right? It's equivalent to 0 when you are crafting the packet. We're gonna see how when you're crafting the packet and also when you are checking through Wireshark. So we have subtypes, yeah, and in subtypes we have different subtypes. This is in bits. So this is just 0, 1, 2, 3, 4, 5. It's a going down. Yeah. So these are just in bits. And then we have the control, which goes at 1. We have the data, which goes at 2, and its own subtypes. So let's apply a filter for this. Let's apply a filter for this. Let me just see for managed. And what we want in managed is beacon, or the beacon frames. Now, beacon frames in Wi-Fi are like the Wi-Fi shouting or broadcasting these packets, telling every devices around, I'm here, I'm here. You know what? I'm here. Yo, I'm here. I'm a Wi-Fi here. When you walk into a building, when you open up or you want to select a Wi-Fi, you'll see a bunch of Wi-Fis, right? Now that is your device capturing those beacon frames, and now that's what tells the device that this is a Wi-Fi. This is a Wi-Fi access point you can connect to. Yeah. Now that's the beacon frames. It's just the Wi-Fi shouting, like somebody standing at archives and then shouting, "Yo, niko hapa, niko hapa. You know, I'm here, I'm here, I'm here." So everybody will notice him, right? So we could do the same thing because there's no way the devices will know this is legit or this is fake. We could also just go and start shouting. Like let's say I go and start shouting, or let's say somebody like or Steve goes and start. Maybe people are used to him being there shouting that, "Oh, I'm Oste, I'm Oste, I'm here, I'm Oste, I'm Oste." Everybody will know that that is Oste, yeah. They can't see him. Maybe he's in a box and he's shouting, "I'm Oste, I'm Oste." The voice maybe it's modulated, so nobody knows if he's a robot or something. I could also do something similar. Bring a similar box like Oste's, put it beside him, get inside the box and start shouting all around. I'm Oste, I'm Oste, I'm Oste. People will be confused. Now, who is Oste and who is not Oste? Yeah, you'll have to open the box to know that this is Oste or this is not. So that is similar to what we're gonna try. Yeah, we're gonna try and try broadcasting beacon frames with the same SSID as everyone or someone on the someone will see on the air. So first, let us now play around in Wireshark and see what we can get here. So let's apply that filter, and what we want. What happened? Learn FC type. Let me remove this. Oh yeah, so the reason why. So that was the reason why. So I want 8, I guess. 8 is the beacon frame, right? Yeah, now that's the beacon frame, 8. But there's only one. I think I captured for a few seconds. Let me capture again. Continue without saving. And then there's none, really? You tell me there's no beacon frame. Or how do I do this? Continue without saving. Okay, let me just end this. Stop and quit without saving. I wonder why I'm just getting one beacon frame. Let's open that again. You're supposed to get plenty. That shows us the devices. And let's wait. Let's let it play around. Let it capture for a bit, and let me apply the filter. What's up? What is up? And then here should be 8. I think the reason why that's happening is because I need to specify that. And nothing is happening. Type 8. Okay, it's not getting any sort of conference, but it's still capturing packets. Okay, if I just get 0.
Yo, Winter,
Yo, hi.
you could as well use the search finder to look to maybe filter out the name beacon or maybe a specific keyword from the packet feature.
Okay, really? Because, okay, so let me just try that. Because what I wanted to do is get the type 0, which is management, and then 8, which is beacon frames. Okay, so let's see this. You see, in this info part, there should be a beacon frame because these ones are data, or these are the data frames. So we have data frames, management, and control. They are only data.
Let me see your preference for this protocol.
What again?
Let me see your preference from the edit tab there up there.
Edit tab and then preferences.
Yeah, then scroll down to protocols.
Let's go protocol and then display hidden
Drop
protocols.
down.
Yeah.
Drop down the protocol thingy.
Awesome.
Yeah, then look for 802.0.1. A couple you. No, a couple you. Just click on
802.0.1.11.
No, that in your yeah.
Is it really informative safe? It should be painful and
No, let's change anything.
let me just try putting. I don't know what this is, but let me just try it and see. Nothing of interest. Okay, that's crazy. I'm supposed to get some beacon frames. Or let me do this then. Let me not set it in monitor mode. And now that Wireshark is failing us miserably, let's try doing the same in Scapy then. So yeah, Scapy is a module in Python. It is a module in Python that allows you to play around with network, allows you to do things like network pen testing, allows you to create your own tools that are related to networking and stuff, allows you maybe to automate some of the networking stuff. So what we want here is I want to do this as quick as possible. I want to create something to sniff the air for the powerful packets, right? And then after sniffing, uh, I want to list or show all packets that have beacon frames. You see? I don't know if you get me. Let me see first. Scapy. Oh no, this is bad. This is bad. Let me just exit here and use Scapy in Z shell and see if it causes an issue. Please don't cause. Yep, now that's okay, I guess. So yeah, so I guess I'm just gonna use a predefined packet. Yep, that's it, I guess. Now let me just create another one. So what we need to do when you want to sniff using Scapy, so uh, here Scapy you can use this as a command line tool, the way I'm using it right now. Yeah. So the first thing when you want to sniff a packet, be it on a wired network or wireless network, the first thing you'll need to do is create a function that will handle. You can just sniff normally and then just print out the function. So, but you want to create a function that will handle those packets like you're getting. So obviously you're sniffing with the goal of manipulating the packets or something, maybe getting something from the packets, something packet injection or stuff like that. That now it's for sending packets. So in this case, what we want to do is listen to all the packets that are around us, yeah, and then from there, now we check for the packets. We check inside the packets if we have a beacon frame or a beacon, a packet which is a beacon packets which is called .11 beacon, right? And then from there now we just get all the SSIDs of all devices around us, or maybe the devices I'm connected to. You can use it with both. Maybe check devices connected to an Wi-Fi, or check devices or app access points all around you. Yeah. So the first thing you'll need to do is like know how the layering works. How exactly does 802.11 packets are represented? Yeah. For that, let me just import one packet I had already captured. But it's not here. Let me just do it is C. Now this what I'm doing now. Is it C script or C script? Let me just move to that directory first. CD, CC, C script, I guess, and then Scapy. Clear will work. And then what you need. Now in Scapy, you can actually sniff or you can actually give it a packet. Like you have a capture and you want to go through that capture, you can just give it read it into Scapy and now start working with it. Oh God, where is it? There it is, and I'll just change this to and is it cyber something? Yeah. And the other thing, Scapy allows auto completion, so you can do an auto completion on this. So this is a capture that I had captured prior that contains some beacon frames. You see. So now I read it into Scapy and I can play with it around. So this capture file will be read as a packet list. Yeah. Now this just says it's a there's a variable that contains list of packets. You can just take it as that. Meaning I can use list indexing or list operations on this. Maybe I can select the first one and you see it gives me the details of the first packet. Yeah. So to make it show a clear view, because I have a very small screen, I can just do .show, right? And then it shows you in layer form. If you check, Wi-Fi starts with a radio tab, and somebody was kind enough to mention that Wi-Fi falls in the radio spectrum on the frequency spectrum, I mean, or the radio part just after microwave, right? So the first thing is a radio tab header or a radio tab section, and then we go to this is different. I think you don't need this. After radio tab, I think it's the 802.11. and then the 802.11 beacon and 802.11 element. Those are the only layers you'll need to create a beacon frame or a beacon packet that you're gonna send. You just need first the radio tab, and then the 802.11, and then 802.11 beacon, and then the information element, which contains the SSID and the information, right? And the length here just say tells you the length of this, SSID. So that's how we're gonna like layer our packet. So what we're gonna do, the first thing we're gonna do is start a radio tab, right? We're gonna start. Oh shit! What did I do? Oh, backward search. Escape. Oh, sorry, forgive me. Okay, awesome. Good position. So I'm gonna start a radio tab. So after radio tab, I'm gonna give it a .11 .11. Yeah, and then after .11, I'm gonna give it now .11 beacon, right? No, it's .11. It's the beacon and then the .11 beacon and then the information element. I think so. .11 beacon. Okay, that won't do an autocomplete. I need autocomplete beacon, and then .11 ELT. Now this is just for information. So yeah, so now this is how our packet is gonna be structured. If you see, if I save this in a variable, let's say our packet, right? Now our packet, you see that it is now structured in a way. It starts from radio tab .11, where the subtype itself is beacon, because we gave it a beacon layer immediately after .11, and then the type is management, right? So this is 0 and this is 8, yeah? And then we get the information element, which contains what we saw, the name of the SSID and also the length or something like that, right? So we're gonna just fill in those information because we have these, yeah. So the first thing we're gonna fill in the .11 packet, if you check the .11 here, 802.11, we have subtype, we have type, management, we have protocol, FC field, ID, address, address 1, address 2, address 3, yeah. So these are what we're gonna put, yeah. So address 1 is like where it's gonna send, yeah, where it's gonna send or the devices that are gonna receive the packet. Now the FFF, this one is the broadcast address, so meaning it's gonna send it to all devices. It's not gonna check. It's not just send to everyone in the air, everyone. It's not just broadcast the packet everywhere, right? And then this is the BSSID or the this is the BSSID or the MAC address of the access point, and then that is in the address 2, and then the address 3 now is like where it comes from. No, this is the BSSID, and then this is where the packet comes from, and then this is the BSSID. So we can say this is the sender, and then this is the receiver, okay? Or the sender, the receiver, and then the access point or the station itself. I'm at the, what is it called? The BSSID of the AP. So we need to specify these. These we really need to specify. These we need to specify. Awesome. So the first thing we're gonna specify in the .11 is, because we know the type, we don't need to set the type or the subtype, but it's good if we just explicitly set it up. So to explicitly set this up, we're just gonna use them the way we're just gonna say type equals to the beacon is 8, and now this is subtype. So type management is 0, and then the subtype equals to 8, okay? And then after that, we proceed to put in the address 1, address 2, and address 3. So for address 1, we found out that we're gonna place in the how many are they okay so it's 8 I guess. Really? No, that's not it, right? That's not it. Let me just confirm if I'm wrong. What's the length again? Minus the, is it 6, right? Yeah. And I placed 7, so that's wrong. Okay, I'm the one wrong. This is should be, yep, and that's enough. Now that's the broadcast address. I hope I'm correct. Yeah, I'm correct. And then the address to here to should be the BSS ID. And now our BSS ID, we need to put it to be at the MAC address of our, what's it called? Our interface. So here it is. This is our interface. Yep. And then sudo, sorry. Sudo iw devices. Yeah. So the address we need to set is this one, which is similar to this one. You see, it's just a virtual interface, so they share the same MAC address. Okay, so this is what we need. We need it to set it as the BSS ID and also as the sender. So what did I do? It's supposed to be in address 2, and then paste it there, and then we set again. We put in the ADR 3, which should be the same. So this, now we have finished the .11 layer. Now we go to the beacon. Now in the beacon, the only thing we need is the ID, which is 0 for SID or SSID, I mean, or you can specify, be specific and just say the ID should be SSID. And then the info, there'll be an info field. Let's just check it again. We have the ID, info field, and then the length. The info field contains the name of the access point you want, or the name of the access point you want to be, like when people are checking, you want it to name it something like our fake access point or our fake Wi-Fi, let's call it that, or router or something like that. Our fake access point needs a name. So in the info is where we're going to supply that name. And then we're going to say the ID equals to 0, or let's just specifically say SSID. The info, let's say equals to evil AP. And then the other one is now, oh, yeah, the last one should be, was it the length? So now the length should be like the length of the info. How long or how large is the string? So you could count it manually, or you could put this in a variable outside here and then use the length function in Python. So in this case, you only have 5 characters. That's the length is 5, right? So we are done with the beacon, and then now we go to the, oh, wait a minute, this should be in the beacon layer. Sorry, this should be in the beacon layer. This should be in the element layer, ELT. So let me just change this so that I don't confuse you. This should be ELT, and then let me remove the end one because I don't want to. And then the beacon layer should just be beacon, nothing else. Sorry, that was a mistake, a very big one. I wanted to complete it. You want to type everything. Shit. So here. So yeah, doc, we have a packet. And now this is the packet we can send. Like we can just we can continue sending and sending and sending lots of these until now we are flooding every devices with these. And obviously they'll say that, oh, there's a Wi-Fi called evil AP around here, and maybe you can put it, you can make it open without any authentication. But now they won't be able to authenticate unless you like give it authentication capabilities. So when we are sniffing, this is how the packet will be layered. So we will have to like check. We'll have to check if the packets we are capturing is .11 packets, right? Which is definitely it. Maybe you can capture all of them is .11, right? You could capture Bluetooth or something, but I don't think so. So when you're gonna check first if it's not really .11, but if it's a beacon packet, right? Or if there's a beacon frame in it, yeah. And then you're gonna check if that beacon frame, if its ID is 0, so for SSID, that means you're checking for AP. If you are not checking for AP but clients, you will now check if the ID is 0, then you don't print out. But if it's 0, then well and good. So how we do that? How do we do that? Let's create a function. So now we start def, and then we let me call it handler, and then this handler will take in a packet, right? And then now in the packet, the first thing we're gonna check if it has the layer .11 beacon, right? So that's the first thing we ought to check. We're gonna check if it has something like the .11 beacon or something. So the first, let's say, if our packet dot has layer, yeah. So each and every packet or the packet list has the packet list exactly. A packet in Scapy has the option of has layer, which now checks if it contains a certain layer. Like for example, if we say .11, yeah, it will check all the packets that it's receiving via this function. If it has the .11 layer, yeah, if it has that .11 layer, we can proceed to do anything, yeah. So in this, we can check if the packet itself, the type is management, which is 0, and right, and the subtype, okay, the subtype is 8, right? Forgive me, this is an assignment operator. Let me change that. Yeah. Now here we have captured all beacon frames. So we want to find a way. To like print out, or let's do it first, and then we'll just start. We'll just continue updating it. So we can say, should I use print or show? Let me just use print, and then I can say print packet.addr1, right? In this case, what was it? ADDR1 was it should be the broadcast, and then ADDR2 should be, I think we should, let me say 2. 2 will capture all devices that are sending these. Let me just say 2. 2 is the sender, right? And then 3 is the receiver. No, 3 is the BSSID. 2 sender, 1 is the receiver. Awesome. So we're gonna print 2. And then now in Scapy, the way now you like sniff and then pass in the function, passing this function so that it can be used to handle the packet. We just type sniff. Yeah. And remember, you can only sniff when you're in monitor mode. So the first argument in Sniff, we have the iFace or interface. Okay. And then the interface name, you remember we call it MMU underscore. What was it again? MMU CIT. And then from there, we pass in the function, the handler, the ren, and then the handler. handler. Nope. Yep, this will error out. The reason why it's telling me that is I ran Scapy as me, like a normal user, but it requires privileges to do any sniffing on the network. So what you're gonna do is I'm just gonna restart, run it as sudo, and then as quick as possible, let's do this handler, and then we have the packet, right? And then we check if the packet dot has layer. So the layer we are checking is the .11, and then we proceed and check if this type, the type is 0, which is management, okay? And then we go ahead and proceed and check if the subtype itself is beacon. Remember, I told you beacon frames are the frames the Wi-Fi screams or sends broadcasts to tell devices that it is an access point. Yeah, it is a Wi-Fi. Like it's what you use or your phone use to identify, oh, this is a Wi-Fi. Yeah. So the subtype should be 8 for beacon, and then here we should print address 2, and then we will start sniffing. We provide the interface, which is MMU CAT, and then the function is provided here, right? So we give it the name of our function, which is this name. And then when you run that, so what it is doing is it is capturing traffic or sniffing for traffic on this interface. And then after that, it is now checking if the packet it has captured is a management frame or management packet. And then it checks if the subtype of that packet is 8, meaning it's a beacon. And then it's it should print it out, but it's not. So I'm gonna do something. It's not printing. It captured packets, but it didn't find the management. So what I'm gonna do is I'm gonna delete this interface. Oh shit. Huh. Sorry, it's this way. Sorry, and then I delete it. Right. Then let's clear that. So let me just go to bash bio. I just start it up bio because I don't want to retype. So MMU CAT sudo ifconfig up, and then let's run this again. And let's wait and see if it will get any beacon frames. Did I set it up? Yeah. It should work. I don't know why it's not. I place this in monitor, and okay, this is crazy. So it should give me the addresses or the MAC addresses of devices that are broadcasting beacons. Yeah, that's what I should be getting here, but regretfully I'm not getting anything. Let me check if there's any. There should be. My device is up. Nope. So yep, we got something, which is, which one is this? That is D83214-2F. So that is the LA, this one. That's Wi-Fi, yeah. So here we have it. So this is how we captured one. I think there are not I don't know why it's not capturing that much traffic. It should be. Maybe it's because it's the virtual interface or something, but I don't know. So yeah, this is it. Let me see. They start this as sudo. Yeah. What if I do this again? Will it show anything else? Okay. So yeah, here it is. We have one. I don't know why it's not capturing others, but this tells us that this Wi-Fi, this is a Wi-Fi access points MAC address. It was sending beacon frames, right? And notifying devices that it's around. So how is this useful? Yeah, this is useful because sometimes people hide their SSID. So you could use Python to like try to like get the hidden SSID. Yeah, but for this one we have just used it to sniff the packets and show us all the devices around us. If I was like I'm connected to the, let me see something, let me try something, let me try I don't know if it's gonna work, but let me try something. Let me try WL1, right? And let's see. Let's sniff in that and see if I can go, if I can get any beacon. Quit and then run that. Let's see. It does nothing. Okay. So I'm not getting anything. Okay, I thought I could sniff my Nini for packets. My default interface. So yeah, so that's how you could create a script or a function that sniffs the sniffing the wireless domain, right? And then it returns all the access points around you. And now from there, you can proceed and do some other crazy stuff like deauthenticating people off of the network. Yeah. So that is for like sniffing, right? So what I want to do is I want to create another one now for sending packets, like sending packets. So I had already created the two scripts here. So for time, because I'm seeing my time is up, I'm just gonna go through it. So I had one, which is an evil scanner and an evil AP. So the scanner is just what we've done. The scanner is just definitely what we've done. You see, we checked for the .11 packet. We checked if the type is 0, if the subtype is 8. We checked if packet address isn't found BSID. Now this one gives us the option to like create a list, which I think I removed. Copy. And then I'm gonna have this here. Yeah, I think that's better. So let me try and run this. No, wait, that interface is wrong. Let me change the interface and let me give it MMU underscore CIT. And then, so what I've done, I have just like what I was doing in Scapy console, right? I just redid it in a script, in a Python script. So the first thing I did was import a module, the way you import in Python. But now I imported everything from Scapy into this script, like into this scope, right? And then now I'm using those layers I've been using in Scapy console in here, right? In a script. Now I've created this script, which if I run, evil scanner, now it should just run the way it ran here. Operation not permitted because I didn't run it as sudo. Control S sudo. Okay, so now that's gonna run, and then it's just gonna do the same sniffing for beacon packets, and then it's gonna print out those beacon packets. So while it's doing that, what the other script was now creating an evil access point. Now, what is an evil access point? If I do something like this, right? Now this is just me listing all the Wi-Fi around me using a tool, right? Not a script. Here you see the script, it's running and it's giving us the output. Yeah. This is Infotech, Real, Attic. These are people on this domain. And somebody goes ahead and even tells us he's on the 5th floor. What an interesting person. So yeah, so if you check, these are what it has captured, right? You could do it using a tool, but maybe you don't have it. You're on Windows, you don't have sudo nmclear, but you have the GUI for checking the Wi-Fi connected, right? So yeah, so what we want to do is, let's say we want to impersonate, let's say Nessus. Let's say we want to impersonate Nessus. Yeah, let's impersonate this, and how are we gonna do that? Control C. Now in the evil access point, yeah. Now this one is pretty simple. You remember when we created a beacon frame, right? When we created a beacon frame on the Scapy part where I showed you each layers. Now that's what I'm doing. I'm creating a packet, which is now a beacon frame with various information. And the only things that matter here is the business ID, ESSID, and the interface for it to send these, right? So in this case, we're gonna change these to be Nessus. And then we're gonna change it here to be, what was it, MMU? Is it MU or MMU CAT? But that's in monitor mode. I think we're gonna use WN0 because that's in monitor mode. We need to send the packets. We're not listening or anything like that. So wait, will this work? Yeah, I think this will work. So yeah, so the thing is, it's gonna broadcast over the network that there's a Wi-Fi called Nessus. Remember, there's a legit one. Yeah, true, there's a legit one, but this is our own. You're gonna check the difference in BSSID. So sudo. So that sending packet. Let's see if this captures it, or maybe let's open another another tab. Let's see if this one's capturing it. There is a capture, but let's use that the terminal command just for the sake. Terminal command. Let's check. It's not working really, but it's sending packets. Courier 5858. It's not capturing this. It should give me two Nessus. It should give me two Nessus. Let me try sending it on MMU. Will that work? Interface MMU underscore CAT. And then run that. Does that send? Let us check on our scanner. Yeah, now check this out. You see how it's spamming? It's spamming the Nessus, and this is the BSID. Now, if I could check my
Winter.
Yes.
Oh, you're not sharing anything, at least from my
Wait,
side. From now, like side.
How long?
Side to.
Oh. Now you can see my screen.
Yep.
Yeah.
Yeah. So what is happening here is, like, now I'm doing a beacon flag. I'm sending packets, many packets, a beacon frame packet, telling people all around me that, oh, you know what? There's a Wi-Fi called another Wi-Fi called Nessus, and if you check, let me cancel it because it has sent enough. If you check our previous script, which was now listening and sniffing for beacon packets, it has captured a lot of nesses, right? Now let's change so that we see, visually see that this is true. Let me change the name and give it another name called, let me call it aka AP, right? So that we know that I'm posing as something very unique. Let me see if we run that. Yep, and then let me check. If we check on the scanner is capturing aka AP. And let me check. Let me check if I could capture it here again. On my end, I can't capture it on my phone. I don't know why it's always refusing. So yeah, so now anybody on this network is gonna see a hacker AP and it's gonna be like, what's going on? Yeah. This is not capturing it though. Okay. This is not capturing it. I don't know why. Am I the blind one? Yeah, this is not capturing the hacker IP. But the script is capturing though. Okay. I think it's because it's on different interfaces. If I'm wrong, because here we are capturing the SSID and it's supposed to be showing on the network. So I don't know why. So yeah, that's how you could pose as another Wi-Fi endpoint or Wi-Fi access point and fool people on the network to connect to you and do some very interesting attacks on this. So this is one way, right? This is one way of doing a Wi-Fi pen test using, not really one way. This is an example of doing a Wi-Fi pen test using Python, right? We came from learning the various security. So here after knowing the various security, here now we've learned how we can capture packets. Now we could now create a new script. I have not created any, but we could now create. Come on. We could now create a new script. Yeah. This script now won't scan, won't sniff, or won't send. It will kick people out of networks, right? It is gonna just deauthenticate people. Yeah. Now you see that's crazy. I could pose as your IP. Let's say I'm seated at the area where in your school where you usually connect to the Wi-Fi, right? I'm seated there and then I see like, oh, you are overloading the network for me. Man, I need to submit this work as soon as possible, and everybody is overloading the network. I could come and create now a similar script. I could come and say I just say my MAC address equals to, I give it my MAC address here, and then now check for everyone connected on that Wi-Fi that I'm connected in, yeah, or on, and then whitelist my own. I now start sending deauthentication packets. You remember that's a subtype of management frame, a deauthentication packet. So 6.7. That's a subtype of sorry. I don't know why I can't find my Obsidian notes. Was it closed? Yeah. Yeah. So a deauthentication packet. Where's the deauth? Yeah. Deauthentication packet is a subtype of the management frame. So when you send a deauthentication packet to either client, maybe you pose as an AP, and then send it to a client, the client will proceed deauthenticating to that machine. So everybody will just be kicked out, and you are the one who's getting the full benefits of the entire Wi-Fi. Or you could also kick them out and then create an evil access point the way we created and do some intercepting. Yeah. Okay. And then same thing, you could intercept and then capture the handshake, the first four handshake, and you use some various tools like uh, hash Ashka to crack or John the Ripper. So it's just the way you use it. It's the way you're gonna use Python for your own way. So you could use those other tools, but you see how this is flexible. I just came from crafting my own packet. I understood where the sender is, where the business ID of the AP is, and where the receiver is, which now that's the broadcast address. Anyway, I'll stop there because if I pass, say if I go past 2 hours, that would be too much. Thank you everyone for being an awesome audience up to here. We will continue this session where I will finalize on the Wi-Fi part and then get into the Bluetooth hacking part in the next session. The next session, we're just gonna do a authentication attack real time, and then we get into now doing the same with Bluetooth scanning and getting people or just connecting to open Bluetooth. Okay, thank you everyone. You are an awesome audience. Any questions? Throw the questions at me. Yeah. Any question? Any questions? Any questions? So yeah. No questions? Really? Nobody's curious about anything. Like I will have a lot of questions if I went through that train wreck of presentation.
Yeah, may I have a question?
Yeah, sure.
Uh, you were switching back and forth in terms of frames and packets. Are they the same thing, or it's totally different? Because from what I
Uh,
know, when you keep on
huh?
saying frames, I
Yeah.
go back to layer two, and then when you talk about packets, my
Uh,
head is in layer three. So I don't know if it's one of the same thing in this in terms of now what you're talking about, it's a totally different thing altogether. And then
mhm.
also maybe when you're talking about the layers now, the layers, is it in a frame header or something? It's
Yeah.
it's totally different.
Okay. Okay. Let me just answer the first one, then get to the second one. Okay. So I use them interchangeably because that's how actually people understand it right better. But they're different. So a packet is like on the network layer, right? And then a frame is on the, I think it's the data link, right?
Yeah, yeah, it's in the data
Yeah.
link.
So I use them interchangeably. And plus, you see, for Wi-Fi, I think Wi-Fi is both in layer one and layer two, if I'm not wrong.
Now, like for example, when you're talking about the radio type, the radio
Mhm.
type will be like layer one,
Yeah, yeah,
and
yeah,
then
definitely.
when you go deeper, then you're
Mhm.
going into the layer two. So when you skip ahead maybe to layer three and talk about packets, I'm like, are you now referring to maybe the IP? Because the network part basically is dealing with the IP. So
You are correct.
I'm not
Yep.
entirely sure when you're switching from frames to like data from frames to packets, is it the same thing still, or
Uh, no.
is it just the frames that are being sent and not even the packet? It,
No,
it's
okay.
just explain, please.
Okay, the entire thing from the radio tab to the last, it's a packet on its own, right? That's a packet being sent, right? And now in the packet we have a frame, yeah? Like now that is when it comes to the part where now the data link part, you see, yeah, in the first part, right? Now this is where I'm talking about the frames, right? We have the management frames and the control frames and the data frames. You are totally right. You are completely right on what you are talking about. But now, I think I'm also a bit misleading because I use them a lot interchangeably. That I called a management frame a packet, but in real sense, the entire crafted, this is the entire crafted thing is what I'm referring to as a packet. And now the other thing about Wi-Fi is it's both on layer 2. You can take it as a layer 1 or layer 2, uh, or layer 2. What should I say? How should I say it? I think it cuts across layer 1 to layer 3, right? Wi-Fi. If you look at it logically, it cuts across layer 2 to layer 3. So you are totally correct by saying that the frames or the packets are the packet is on the lower layer and then the frame is a bit high up the stack. Or is it the frame is the lower one and then the packet is a bit high, right?
The frame is low and then the packet is higher.
Oh,
But
yeah.
altogether, I don't
No.
know. It's supposed to be encapsulated. So the packet
Yeah.
is like something else, and then it's joined together with the frame. So when you switching the board from packet to frame, it gets, for me, it got a bit confusing because
Confusing. Yeah.
yeah, because I don't know. And then maybe, like it's a whole data, and where is the data in itself? So is the data within the frame now, it's it's the one that is being encapsulated with this particular frame that you're creating. So that for me, that was quite confusing.
You're correct. You're correct. And I'm realizing something because if I take these as if I take up here up to here, this is the first part as the no up to radio tab, right? Up to dot 11 as the frame, then yeah, I think this is the packet itself, and then this is where now the data is being is in. It's in the dot 11 ELT, which is now the information packet of the beacon. So this is a beacon packet, right? And then this is a management frame. So meaning EM up to here, it's where now I'm defining the frame. And then from there, this is the packet itself. And now that's what makes it a beacon packet, right? Which has been broadcasted over the air to notify you that the Wi-Fi is around. So you are correct, and you've made me realize something. Now, from here to here is the frame. So meaning a packet is inside a frame, right?
Yeah, it's the frame, and then now the packet comes next.
Yeah. So yep. Thank you for asking that. That was a learning experience for me because I was just using them interchangeably. Thank you. Any other question? No questions actually. My age? Am I single? Why are you not asking? I'm not a simp. Eh? Have you heard of toxic masculinity? Now that's the definition of me. You're lying though. I'm lying though. You guys have no questions similar to what Anis has asked? Just ask me because I'm also learning. Because if I talk too much, I won't learn. Anyone with a question about where Python can be used? Okay, then if there are no questions, I'll pass the mic back to Zeddy. Is Zeddy still in? She has left when I just called her. She has left. So yeah, if you guys still have any question to ask me, let me ask me before Zeddy can close up. The session will be recordings will be there. It will be shared, I guess. So look out for it. And let me just text her if she's still here.
Hello, Byron. Hello.
Hello.
When is the next session?
Okay, the next session. I don't know. I'll check with Zeddy and see. Maybe next week.
Okay.
Next week, same time, I think.
Yeah, that will be good.
Awesome. Let me just confirm with her so that I see if she just left. I don't know any other officials of the MMU CT, because I think it's time to close and I can't just leave without you guys having the
I am present.
yeah, you can. The mic to you.
Okay, thank you. Thank you so much, Winter, for coming to train us in this session. And thank you for everybody who has sticked around until this time. It's late. And so we are grateful, looking forward to part 2 of the session.
Yeah, what will be interesting. All of you leave your Bluetooth on, so we'll check out some interesting stuff on Bluetooth. Okay, thank you too for having me. I had a lot of fun just yapping on wireless security because it's one field which is being overlooked nowadays. Everybody's jumping into the meat of web system exploitation, reverse engineering. We are forgetting we have a pretty little Wi-Fi or wireless security, so which you can play around with. Yeah. So mostly this is now you get to just think around with the radio frequency and so on. Okay, thank you. Thank you guys and thank you for the support. Have a great night. I think that's it. Yeah, thank you. Just leave
Okay,
it
good
to
night, Sue.
okay. Okay, to have the box.
Thank you. Good night.
Is Chris.
Yes.
Wait,
Hi,
so
Zeddy.
okay. I've really struggled with my network.
Yeah, figured.
Have been on and off, but
Yeah,
I
so
followed from the start.
yeah,
I appreciate the way you've carried out the session. You started by laying the foundation of what Wi-Fi is, the Wi-Fi security basics,
yeah,
and then you listed to us the number of tools we can use while handling security. That's right.
yeah,
And you then began explaining where Python comes in and
yeah,
how it chains all the tools together. So
yeah.
I followed up to somewhere, but I was on and off, on and off. But personally, I want to say thank you on behalf of the CIT Club, MMU. We appreciate your time. We appreciate the fact that you've given it your all for the benefit of our members. And I don't know if you have finished everything you had to say about Wi-Fi security, but maybe we can talk later concerning maybe what is left and the next session that we will have.
Okay,
At
sure.
least I also appreciate everyone who was able to join. I'm sure we have all learned a lot. And also, if you have any materials you can share with us for anyone who wants to go deeper in learning more about Wi-Fi security, because I believe some of us are beginners, especially in when we talk about Wi-Fi security. So you can also share with us anything, any learning materials, any knowledge, and we'll
So
appreciate.
so you got me there. I didn't prepare that, so maybe I compile and then in the next session I just give it out because I didn't prepare it. There's a lot of materials and maybe I should just prepare and write exactly what material and where it applies on the wireless security spectrum.
Okay, fine. Were you able to complete everything about Wi-Fi security?
No, Wi-Fi is large. I just give them an example and where Python comes in. So when we want now to go into Wi-Fi security on its own, that's totally different with what I was doing. I was doing Python for Wi-Fi, you see. I was like showing them, because I started the basics, I just wanted to, for those who don't know at all anything about Wi-Fi, to really know what I was doing. Yeah, what was I actually doing? And now, if it was for Wi-Fi, I could now have gone back to aircraft NG, captured the handshake, shown them what the handshake contains, and all that and all that. But we can still have other sessions for the same because I've not finished on Python for Wi-Fi. It did not perform at the authentication attack. So we will on the next session, maybe I'll start with the authentication and then go next to Bluetooth and finish up.
Okay, fine.
Yeah.
Thank you.
You're welcome. Thank you too.
Okay, good night to everyone.
Good night.